open it up. Anybody else? Okay.
What drove you guys to want to do research? Was there a defining moment in undergrad where you're like, this is what I want to do, or?
Well, I thought I wanted to teach, and I'm trying to remember when it was that I decided. I guess somewhere during my graduate career, I really can't remember. You know, I mean, I said I wanted to teach, but you get to graduate school and, okay, maybe you do a little as a GSRA, no, what is it, no, GSI. But then you spend this enormous amount of time just doing research. And so actually that's what you build up your skill in. And then I decided that was for me.
For me it was like a very specific undergrad course, which was organic chemistry. Yeah, it was organic chemistry. So we had actually synthesized some compound, and the only instruction that was given to us is you can use any chemical from the lab, you can do whatever you want. You have a week's time. So that actually got me hooked into doing things on my own. I ended up working for that professor. I really loved research. So I think it was just that one course that actually stimulated me to research. Yeah, but I really like teaching, so I might go to teaching. So I was a GSI, so I really like teaching. So.
What other than teaching are you considering after grad school?
No. So I want to actually be a research professor, so that's both teaching and both research and teaching. So I've taught three different departments here: genetics, physics, and biophysics. So somehow I really like the biophysics aspect of teaching, trying to understand physics of biomolecules. So probably I want to teach something like that, develop courses in that kind of thing.
Are you planning on going back to India, or?
Yeah, going back to India. I want to do a postdoc here and then go back to India. That's it.
Other people have questions?
How many of you have pre-meds here? So, how many of you want to go to grad school? Why grad school?
I do research now, and I really like it. I'm still deciding whether med school or grad school, but maybe I'm doing both. There's a guy in my life who started out in grad school in physiology, and then he moved to med school, and that seems kind of interesting. A really long time, but I mean, if I like what I'm doing, I'll just keep on going.
That's something about it, consider. I'm 28 now, and my parents are you're still in school. It's always going to be the case, whether you're in med school or in grad school, there's always going to be that one thing, there's always going to be that inevitable comparison to someone who is who's done some master's degree in business or something and is learning like crazy, and so be prepared for that.
Inspiring.
You get your freedom, so that's that advantage.
Mm-hmm. So we're focusing in this SSG on writing in science. So our semester project is to pick a topic of their choosing that's covered in the course and write sort of a review. They have to read a bunch of papers and then write kind of a compilation about it. So can you tell them a little bit about your experience with scientific writing and the peer review process? Do people generally accept your work, or is it hard to get into anywhere? Or if you get into a certain journal, do you often try to apply to that journal again?
My experience is very limited. So I had some experience in undergrad and some in grad, but not really a lot. Okay, so this is my motto. You always try for a top tier journal. You're sure to get a reject from that. So and then you try for the actual journal that so that's sort of you sort of gauge the extent that people want your thing, and mostly you guys know about impact factors.
Mm-hmm.
Impact factors. So it's basically you can call it as a ranking of journals on how much things have been cited previously and so on. So for instance, if you're going to have like if you're going to be like this review thing, a lot of people are going to cite reviews. So for instance, annual review of immunology is going to be like this 58 or something, and if you're going to have like some crazy, really low level journal, it's going to be like 0.1 or something. That's just to give you a range so that you have an understanding of it. So as you go higher and higher, things get more rarefied, so you're not really going to have a lot of journals in the top. So ideally, for instance, a good journal would be PNAS, which would be like around 20, and a JAX would be like around 10 or 11 or something. So I always think a good journal, it also depends on the field in which you are in. For instance, I think as a biophysicist, like anywhere between like the 4 and 10 is like the standard thing, and that's what we're trying to get. We always apply for something that's much, those are actually undergrad. We always try for something greater than that, but then most likely you're going to have this lengthy paid thing that says, so an undergrad was a computational biologist, so all years are going to be like, hey, this is not computation, there's no experimental data to support this. So you actually go for something that does not require, you're just hypothesizing stuff. So that way you go for, mostly it'll be accepted with small changes. You'll have to probably do another simulation or something as an undergrad. And here it's mostly like, so this part needs to be elaborated, so probably you need a control experiment here with the next but it generally gets accepted. I know it's been rambling, but yeah, it's very
So, I've had papers that go through very quickly. Quick is typically a month. I had one paper recently that was 2 years, and that was a bloody battle. But in general, writing the thing, I can tell you about journals if you want, but I didn't used to enjoy that aspect of it, but I really do now. I like getting something down where it says exactly what I found in a really accessible way. The thing I didn't really realize when I first started off was that if you produce this, even if it's the greatest paper, if nobody can understand it, that's it. It's finished. It would be very, very rare that anybody would read it and get something from it. It would be forgotten. So the majority of papers that are published never get cited again, which means nobody's ever read it or used it. And so I find a lot of satisfaction in producing something that I hope will be read by you.
Interesting follow-up on that. So everyone here knows about Gibbs tree and that too. So Gibbs was this professor of Yale University. So this was like the 1870s or something. So he just stepped out of the Connecticut, out of like 10 miles of Yale just once in his life, and he always was confined to that. And he used to give, so Gibbs is probably the greatest guy in thermodynamics according to me, and the least understated, is the maximum, is really understated guy. The reason for that is because all his lectures are so incomprehensible. He used to give everything in his lectures, and there used to be like one student per year in his class. No one used to take it. So, and he used to publish in like Philosophical Transaction of Connecticut or something, some really weird journals, And so no one knew about his work for like really like 30 years or something. So it becomes important that you write really well. Yeah, just understand this point. But yeah, it becomes important you write really well. Otherwise, no one's going to really know. It's just one example. Like I can tell you like three or four examples.